So first of all, so these properties of logarithms really relate back to a lot of your properties of exponential functions. For example, we all know what happens when you multiply like bases together with exponents. What do you do with those exponents when you multiply them together? Add them. So I know this is x to the a plus b. Now, what we're going to be experiencing now in this year in calculus is actually undoing those properties of exponents. In other words, what you now have to recognize is when you see a plus as an exponent, when do you add those exponents together? You add those exponents together when you do what? When you multiply like bases. So you've got to recognize these properties both ways. For example, anytime you see a plus as an exponent, I can rewrite this as x to the a times x to the b. So again, what we're going to be looking at, especially in some sections in this chapter, is undoing the properties of exponents. So anytime you see a plus in your power, remember, you can undo it. Now let's talk about your logarithmic property. When you see the log of a product, so remember, when you see a product inside of a logarithm, you can expand it out through what operation? You can expand it out through what? Addition. So remember, log of AB is equivalent to log of A plus log of B. It doesn't matter what the base of the logarithm is. This property applies to all logarithms. So again, if you look at the natural log, you can look at this as the natural log of N, the natural log of A, plus the natural log of B. So remember, we use these properties also to condense. What I did in this first example was I expanded out that log of A times B. But remember, you can also use this property to condense. Natural log of A plus natural log of B, we can bring this together through what operation? Condense it to a single logarithm as the natural log of AB. So you have to be able to use the properties both ways, expanding them out or condensing. Remember doing this from last year? Dividing. So going back to your exponent properties. What happens when you divide like bases? You subtract them. So now looking at your exponential properties, going backwards, do you agree with me that if you see a minus b in the exponent, you could also write this as x raised to the a plus negative b? Would you agree with me that they are equivalent? So I can undo, when I see subtraction in my exponent, I can rewrite it as an addition by adding the opposite, a plus and negative. And then I can undo the properties of exponents by writing this as x to the a times x to the negative b power. And when you see a negative exponent, what does that indicate for you to do? You simply take the 1 of x. You simply take the reciprocal. So remember, all of these are equivalent, and that's the thing you have to get in the habit of doing. When you see addition and subtraction in those exponents now, you're going to be rewriting these a lot in terms of a product. So right here, when you see x to the a times x to the negative b, remember when you have a negative exponent, that means you rewrite as a positive exponent, moving it to the denominator in this case. All right? Now, logarithms. When you take the log of a quotient, remember you can expand this out as a subtraction. We can write this as the log of A minus the log of B. Remember, this property also works in condensing natural log of A minus natural log of B. Anytime you see the difference of two natural logarithms, you can bring this together through division. Your exponent rules. When you have a power raised to a power, what do you do with those exponents when you have a power to a power? You do what? Multiply. So remember, this is equal to x to the a times b. So with your logarithms, if you have the log of a raised to the b power, so when you have log of a raised to the b power, remember you can take this b, you can write this now as a product. You can write this as b times the log of a. Again, this also applies if it's a natural log. Be careful with some common errors we see with logarithms. Sometimes students want to do this. Remember when you have x to the third plus x to the fifth. Remember, this is not equal to x to the eighth. Remember how you add like terms in algebra. When you have the log of a sum, when you have an addition sign inside of a logarithm, you're stuck. Unless you can do some factoring and write it as some kind of product, you cannot do any more simplifying with this sum. This is not equal to the log of A plus log of B. You cannot split up the addition. Same thing with your natural log. If this was the natural log of A plus B, it's not equal to the natural log of A plus the natural log of B. Just like subtraction, when you're doing exponents, x to the fifth minus x to the third is not equal to x squared. You can only add and subtract like terms, those that have the same base with the same power. Just like addition, if you see subtraction inside of your logarithm, unless you can do some factoring, you are stuck. There's nothing more you can do. The log of A minus B is not equal to the log of A minus the log of B. Same thing if this was a natural log. So just remember, you cannot do any expansion or condensation if there is a log with an addition or subtraction sign inside that logarithm. You are kind of stuck there. The only thing you do is factor. Do some factoring and see if you can do it that way. All right, so some other properties of logarithms that you need to be familiar with from last year. First of all, log base A of 1. Remember what the log of 1 is equal to. Doesn't matter what the base is. Log of 1 is no. So let's talk about this. No.
0.
There you go, 0. If I throw out enough numbers, one of them has to be right. When I ask you to evaluate a logarithm, you are solving for the exponent for the base. So when you see log base A of 1, what this question is asking you to do is asking you to take A raised to some powers equal to 1. Anytime you're evaluating a logarithm, you are solving for the exponent for the base of that logarithm. You're solving for exponents. So A raised to what power is equal to 1? Well, any base raised to a 0 power is equal to 1. All right, so it doesn't matter if it's log base A of 1, natural log of 1, it's always 0. So then log base A of A, now what would that be equal to? 1. There we go, because A, my base, raised to some power is equal to A to the first, because this A has a power of 1. So there's your 1. I'll jump to B right here. Kind of very similar property to B. Log base A of A to the R is just going to be what? R. Now, we talked about how exponential functions and logarithms are inverses of one another. Remember your composition rule. Anytime you take a function and do a composition with its inverse, they cancel each other out. So notice A raised to some power and log base A. They are inverses of one another. So what's going to happen is A raised to log base A will cancel each other out, and you're just left with an N. So let's take a look at log base A of 1 over N. Well, using your division property of logarithms, I can rewrite this as log base A of 1 minus log base A of N. And what did you just tell me log base A of 1 is equal to? 0. So remember, this is equal to negative log base A of N. So another property we'll be using when we get into solving equations. Just like you can add and subtract to both sides of an equation if m is equal to n. you can take the log of both sides of the equation. So we can write this as log base A of m is equal to log base A of n. You can take the log of any base of both sides of the equation. Kind of the reverse of f. If log base A of m is equal to log base A of n, then what's the relationship between m and n have to be? M has to be equal to n. Change of base formula. Change of base formula we use for two things. One, when we get into solving equations, which we will, if you have an equation that has logarithms with two different bases, you have to use the change of base formula. Or if you do not have an 84 calculator that does not have the updated operating system, you're going to have to know the change of base formula. So people think, oh, I can forget about change of base because I have a calculator that has the log in it. That's not true because that you run into equations you need it to solve. So the change of base formula, you can take a logarithm, change it into any base you want. So for example, if I have log base b of a, so b is my base of the logarithm. If I want to change it into a natural log, by the way, when I say natural log, what is the base of that logarithm? E. We call it the natural log because E is what we refer to as the natural number. So the way the change of base formula works, if I have log base b of a, I would take the natural log of a and divide it by the natural log of the base. Oh, your base goes on the bottom. Common logarithm is a logarithm of base of what? 10. This has a base of 10. We do not have to write, again, you will never see the log base 10 written. You just see log of a. If there's no base written, then we know that it's a base 10. Just like if you see ln, you know that's a base e. All other bases have to have that subscript after it's what the base is. So we could write this as log of a over log of b. On your calculators, whether you have an 83 or an 84, right next to the number 7, you see log. So there's your base 10 logarithm. Right underneath of that, right next to 4, you will see the natural log. There's your base of e. So again, doing base 10 and base e, you have the calculators right there. If you have the updated operating system, if you go under Alpha Window, under option 5, you will actually see this option for log base. So when I choose option 5, there's your option that you can actually type in any base that you want. So log base 4, let's say, of 7, and you'll get some decimal. So if you did not have the updated operating system, or if you have the 83s, you do not have this feature. So what you would have to do to type in log base 4 of 7, you would have to use your change of base. You would have to do the natural log of 7 divided by the natural log of 4. So, like I said, if you do not have an 84, if you have an 83, you have to use this change of base. Okay? And I will see you guys after lunch.